Greetings, everyone. So we're going to work on finding the inverse of a rule. And here's the first rule, or here's the rule we're going to try to apply this to. Now, what you should do when you first see this is you should recognize what the graph looks like. And that's an important step because you want to have an idea of what the inverse is going to look like, and then some of the other relations that we've talked about switching x's and y's is going to be important to us. And so if you think about this graph here, hopefully you recognize this as a square root graph, the upper half of a sleeping parabola. Because we have this minus 2 right here, that means we've got to shift 2 units over to the right like this. Because of this plus 1, we're going to shift up 1 unit. Okay, so the graph starts right here, and then this 3 is a stretch factor, which means it makes it stretch more vertically upward like this, and it's going to look something like this. And the reason why you want to again have this in mind is because you want to know what the graph looks like, have an idea of what the inverse is going to be. But also, between the function and its inverse, there's a domain and range relationship that we have to be aware of. So for this function here, the domain of f, the set of all inputs, the set of all x values, well, if you think about it, or look carefully at this graph, I can plug in positive 2 because of that minus 2 there, and then the graph goes in this direction, so any value over in this direction here is going to be part of my domain, or the domain of this function. So this is x greater than or equal to 2. Now the range, on the other hand, is the set of all possible y values. So the y values start at 1, and then they move upward from there, and they never stop going up. And so it's all values of y that are greater than or equal to 1. Now, we're going to come back to the relationship between f and its inverse in a moment as to what the domain and range are and how they're related, in case you don't remember. So just hold that off in your mind for a moment. So we want to be able to find the inverse. And so to be able to find the inverse for this, the technique that we worked on the other day was switching the x's and the y's and then solving for y. So keep in mind that y is an output. So y is what f of x equals. So I'm going to change f of x to y from the start so that I have an understanding of what I'm trying to do. So now to do this right, what I got to do next is to switch the x's and the y's in the equation that's written here. So I'm going to interchange these, and when I interchange those, we'll have x is equal to 3 times the square root of the quantity y minus 2 plus 1. Now once I've made that switch, now I can go ahead and start trying to solve and figure out what y equals. And by solving this, I'm just isolating y. So I'm undoing all the things that have already been done to y to get y all by itself. And so if I'm looking at the right-hand side, the first thing I want to undo is the plus 1 that's over here by subtracting 1 from both sides. And so on the left-hand side, I end up with x minus 1. And on the right-hand side, I have 3 times the square root of the quantity y minus 2. So what's the next thing that I need to undo? Well, the next thing that I need to undo is this multiplying by 3 right here. And the way we undo multiplying by 3 is to divide by 3. So I divide both sides by 3 so that these cancel on this side. And then I'm left with, I'm going to rotate the sides here. It doesn't make things different. I'm going to put the square root of the quantity y minus 2 there. And on the left-hand side, or rather now on the right-hand side, I'm going to have x minus 1 over 3. Let me double check that because switching screens, I might have forgotten. Alright, so what's the next thing I need to undo? Okay, well the next thing I need to undo is the square root. That's what's happening to the y side right now. And to undo the square roots, I'm going to square both sides like this. And so now that I've squared both sides, on the left-hand side, the square and the square root are going to cancel, leaving just the quantity y minus 2. And on the right-hand side, I have this x minus 1 over 3 quantity squared, like that. Now you could try to simplify this if you like, but we're just going to leave it alone and work with it that way. The last thing we have to undo now is the fact that we are subtracting 2 from y, so I need to add 2 to both sides, where these cancel here, and I'm left with y is equal to, we have this x minus 1 quantity divided by 3, that quantity squared, plus 2. This is our F inverse. This is, what we've been asked to find. Okay, we're trying to find the inverse. So this is F inverse of x. Now, we should slow down and try to make sure that we really understand what we generated here, because the graph that we're dealing with here, this whole thing, this is a parabola. And if you remember, taking the inverse of a parabola gave us a sleeping parabola. But we started with a square root graph. The square root is only half of the sleeping parabola. So we can't have a full parabola be the inverse of only half of the sleeping parabola. We have to go back and do something or make an adjustment. Okay? So, well, what's the adjustment? How do I know which half to take? Well, remember before I said we were going to figure out the domain and the range? Well, the thing that relates the two together is that when we have the domain of f, that becomes the range of f inverse. And the range of f becomes the domain of f inverse. So they got switched. And by switching them like this, or by recognizing that they get switched, we know how to restrict our domain and our range. So, I'm sorry, just collecting my thoughts here. We are going to change the variables here because we haven't done that yet, but let's go back and take a look. So the domain of f inverse is the values greater than or equal to 1. So let's get to that last screen here. And so the domain of this function here, of f inverse, now I'll switch it to being x values. Over there it said y greater than or equal to 1. Now it's got to say x because we're talking about the inputs to f inverse. These are going to be the values of x greater than or equal to 1. So we're not taking the entire parabola, we're just taking from 1 and everything to the right of it. Now hopefully you recognize that 1 is part of our vertex because this x minus 1 here. The other part of our vertex is going to be with this the plus 2 that we have over here. And so if I just use that portion only, where x is greater than or equal to 1, then I have the inverse of the original square root graph. Again, I don't want to use the whole thing because I started with half a sleeping parabola, so the inverse should be only half of a parabola, not the whole thing. Now, one thing that we also worked on the other day was a function composition relationship. I know that sounds like a lot to say, but what we were saying by that is that if I take my function f and I input f inverse, I should end up with x. Also, if I start with f inverse and input f, I should end up with x as well. And this is an important relationship for testing out whether or not we have the correct inverse. Because if we don't have the correct inverse, then we got to fix it. We don't want to have that mistake. So let's run through how this works really quickly, if we can make it quick, and see if we can get a better understanding of how this works. So if I'm going to take f of f inverse, I should probably have what those functions are in front of me. So let's make sure f of x is equal to, was the function we started with, 3 root quantity x minus 2 plus 1. And then f inverse was x minus 1 over 3 quantity squared plus 2. It was like this. So how am I going to show this relationship? All right, so f of f inverse of x, follow along, f of. So that means I'm going to place all of this stuff in here. Okay, all of this stuff right here gets placed. I guess that was a little too much. But all this stuff here gets placed inside f. So I'm going to have x minus 1. I got to back up a little bit. X minus 1 over 3 squared plus 2 like this. So all of that stuff got placed inside there. Now, what I got to do is take all of that stuff and it gets placed inside the x that's right here in f. So when I start to write down f, because that's the function I'm dealing with right here, anytime I see an x, I got to put all of this stuff inside. So this becomes 3, because my function f starts with 3, square root, oh, there's the x, so I got to plug in this x minus 1 over 3 quantity squared plus 2 minus 2, because the minus 2 that was in the square root to begin with, plus 1. Now from here, hopefully you can see that these are going to cancel. And then hopefully you can also see that this square and this square root here are going to cancel. So I'm left with, all that equals 3, and then I have x minus 1, excuse me, I'm having technical difficulties, x minus 1 over 3 plus 1. I have that part left because the square and the square root cancel. Now here, these 3's cancel, and I'm left with x minus 1 plus 1, and I do get x, which is what I expected to get. If I didn't get x, then I've made a mistake somewhere, and I got to go back and fix it. Now you should practice for yourself what happens if I switch the order, because we also said if I switch the order and do it in this order here, that I should get back x as well. For your own practice, you should try that out, and if you're stuck on it, then you should ask me about it tomorrow or next time you get a chance during lunch or after school to make sure that you understand how it works. All right, go study.